This Ada lecture is going to be dealing with strings and looking at them in more in depth than what we looked at before. And this will help introduce the next concept of more advanced array usages. So let's start off with our basic string, where we have data of a particular type, and we have to make sure that it has a fixed size. And if we want to get some information, and then we also need to have a content, which is going to tell us which particular place in the array actually holds good values. Because by default, I'm going to go through and let's just output this by itself. So let's read in the word hi. So we can see that I get what I typed in, but we've got 1, 2, 3, 4, 5, 6, 7, 8 extra characters, which makes sense because our string is of size 10, of extra information. So to combat this, we have to use what's called an array slice, or to only output the information that we know in the array is good. So if I type in hi, now I only get hi. Whereas if I were to type in hello, I'd only get hello. Now this is obviously more than 10 characters. That is only 10 characters. So Ada protects us from having to use the exceptions that we learned about in our last lecture to handle that particular case for our input. Now, one of the issues with this is we have no idea of really knowing how much we need for input at runtime, and if we guess wrong, there's nothing we can do about it because you would have to go re-edit the source code, which creates a problem for some particular types of software. And the way around this is using a declare block. So what declare essentially says is we're going to have a, let's change this content around to a size, and let's change this to get size. Now I'm going to declare a new string whose type is going to be a string, but the size is going to be from 1 to size. And now I'm going to have my own begin and end. And this begin allows me to do a get line of new string, and we'll just say capacity. And this will ignore the new line that the get has left in the string, and then this will read in some information, and then I can do a put line on new string from 1 to capacity. So what this allows me to do is to create a string of whatever size I enter. So let's look at a particular input case. I'm going to have 5, and then I'm going to have the word hello. So let's remake our program. and run it with this particular input case. So I'm able to read in and to output this. If we run this manually, well, let's create a string of size 8, and this is a test. So we got an exception error in this case because probably dealing with what's happening in carriage returns, so on and so forth. So this is a test. So let's rerun this. So sometimes when we're working, doing console I/O may not be a good idea due to the order and the method of what is typed in and what's actually produced. So this is a new capability that will allow you to declare your strings of whatever size you need for your input. So that means for input files, we could see something like, well, this next string is going to take up, say, 20 characters, and then you would have essentially the responsibility to provide 20 characters after this. Now, this is a test, is not exactly 20 characters, but if I were to go on for 20 characters, so that's 10, that's 20. So I could read in a field size and then read in all of the information for that particular field. Now, we have to use this declare statement to do this because at runtime, we have to know exactly what the size of everything is. And the only way around that is to let the user know that we are going to declare some new information or some new variables. And those new variables may indeed depend on information that has been included earlier in the program. So this is another example of Ada's readability information with this. Now, as we're looking at reading new information, let's look at what happens once we actually start using said information. So let's go to do a data, and let's just say input, and this is going to be a string from 1 to 5. So this would be something like hello, and let's change this around to be hi. So we've got two different strings here. Let's just output them to make sure that they work okay. And no space allowed here. So we've got our two different strings. Now, if we wanted to see if these two strings were equal, we could say, well, if data equals input, then so in this case, they are obviously not equal. And then if we want to make sure that they were not equal, I always get which one of those used wrong. So if data is not equal, obviously in this case it says they're equal, but it would truly be they are not equal. Now, if we wanted to combine these so that data held whatever data had and whatever input held, in other words, combine the two together, let's see what happens when we run this. we got a constraint error. And that's because I tried to concatenate these two strings. So I've got 5 characters and 2 characters, which is 7 characters, that were all trying to be stored into this particular character. So one thing we might be able to do is to use the declare block that we had before to create a string of a larger size that would be able to accommodate both of these two strings. Now, the next thing, if we do have a string that is larger than another one, so in other words, let's go through and change this so that both of these are equal. Let's see what this prints out. So let's run this. We have a constraint error now because our length check failed. And as we're looking at this, they're both equal, but one issue is that this doesn't even assign because we're missing 3 spaces. So whenever we're assigning data, it has to be exact. And whenever we're comparing, they have to be exactly the same as well. So obviously these are not equal now. If we get rid of the U, they are equal. So what we are seeing with Ada is we have a deep copy type of comparison. What I mean by that is we aren't looking at the memory locations. The size is taken into consideration, obviously, because if you try to compare two strings and they're different sizes, they are obviously not equal. But whenever they are the same size, we can see that the information is being compared character by character. Now if we go back to our original comparison, where we have high and then high with several spaces, well, and we know that in this case we know inputs particular or data size. When we're working with this, then that means I can refer to just one small piece of our input. So if you know the size of the strings, you know specifically how to compare them properly. And this is important because if we think back to our earlier example where we say have a string of say size 20 that leaves us with say 15 extra spaces in the string after we type in some input, we can't just compare string A to string B and expect them to be equal. You have to compare the part of the string that actually has the information that you are wanting to use in it, because if you do not have the correct bound in it, then you will have many different problems. So let's copy and paste some code from an example just to illustrate this a little bit more. So if I declare a string size 1 to 10 here, and then a string up here that contains this information, I cannot assign them because they're different sizes, obviously. If I make sure that I am very careful and everything stays the same, it will be fine. If I try to overload it, compile error. If I try and combine the information, it won't work. Now if I could try to combine the smaller one and the larger one together with the right number of characters, that will work. So that's an example of how ADA and strings work. Now, if we add in a few different with statements to our code, and these are unbounded strings. Essentially, this means that we now have a type of string that works much the same as a regular Java string. So what this code will allow us to do is to essentially assign and change and work with strings to our heart's content, and everything grows and shrinks magically, and we no longer have to worry about the size differential. We still do have to worry about the correct characters as they are being compared, though. So if you want a string and be able to provide concatenation and assignment without having to worry about the initial size of the string, an unbounded string is the best choice for that. However, it is not the best choice considering performance in some cases, because if you need to know exactly how much memory is being used, an unbounded string will not allow you to do this. So this is a lecture that's dealt with strings in a little bit more depth and detail, and shown how to use slices and declare blocks to create new strings of different sizes at runtime, and also to use unbounded strings so that declare blocks are not necessary. This concludes this lecture.